When you are solving a logarithmic equation, you want to make sure that you have simplified your expression and your equation to a logarithmic expression equals a number. And then once you've done that, then you can rewrite it in exponential form and see if you can solve that. So always make sure that you are checking any solutions at the end. And remember that logarithms have a very specific domain where it's from 0 to infinity. So always make sure that that m, whatever that happens to be, is greater than 0. So always important that you always check your answers. All right, so let's work through some examples. All right, so here's our first example. We have log base 2 of x minus 4 equals 3. So I'm going to change that. I have my logarithm completely isolated, so let's change that to exponential form. So that would be 2 to the third power equals x minus 4. 2 to the third power is 8, so 8 equals x minus 4. I'm going to add 4 to both sides, and I get 12 equals x. Again, make sure you check, plug that 12 back in, and make sure that that works. So always make sure that you are checking m at the end. So there is my final answer. My solution set is 12. All right, so notice, not too difficult. Okay, so all the rest of these examples are just going to have little different things that might be thrown in to try and trip you up. So first thing that they might do, they might have a number in front of the logarithm. If that happens, please divide both sides by that number before you even get started, because remember, you want to isolate your your logarithmic expression. So that would simplify to natural log of 3x equals 2. Okay, so I have now isolated my logarithm. Now I can change this to exponential form. So it's a natural log, so it's base e. So this is e to the second power equals 3x. And then to isolate the x, you just have to divide both sides by 3. So my final answer is e squared over 3. And then again, of course, you would check it to make sure it works. And you would get, that is your correct answer. E squared over 3 is my exact answer. So that is my solution set. So notice, it's just a matter of you getting it down to that logarithmic by itself. Okay, another problem that you might see that they might throw at you is that they have logarithms where you have to use those logarithm rules to condense it into one logarithm before you can solve. So this is a great example. Notice we have an addition problem. So log x plus log of x minus 3 equals 1 means we can put those logs together using the product rule. So we're going to keep the common log, and then we're going to multiply x times x minus 3. And that equals 1. So again, that was that product rule when we were condensing our logarithm. And now that I've got the logarithm by itself, now I can change it to exponential form. So again, this is a common log, so this is base 10. So 10 to the first power equals x times x minus 3. So that is 10 equals x squared minus 3x. So that is a quadratic. So I'm going to get everything on one side and set it equal to 0. I can factor that quadratic, so that's good. So that's x minus 5 times x plus 2. And then solving each of those factors, I get a solution of x equals 5, and I also get a solution of x equals negative 2. Now, this is where it's very important that you pay attention to your domains, because I have this log of x, remember, this has to be greater than or equal to 0. This must also be greater than or equal to 0. So this first logarithm tells me my x's must be greater than 0. This second logarithm tells me that my x's must be greater than 3. So x greater than 3 is the most restrictive environment. So I know that all of my answers that I get for this problem have to be greater than or equal to 3. So I automatically know this negative 2 is not going to work because that's not greater than 3. It's not even greater than 0. So I definitely know it's not going to work. So that leaves 5 as my only possibility. Make sure you check it. Turns out it does work. So negative 5. And even if you forgot your domain restrictions, when you check that negative 2, you will find that negative 2 will not check. So always very important that you check your answers every single time. All right, so the other thing that could happen when you are solving these equations is that you could have a logarithm on one side and a logarithm on another side. Okay, if that happens, you need to make sure that your logarithms are the same base. So if the logarithms are the same base, then the numbers m and n will be equivalent. So that's another thing you can do. And again, make sure that m and n, whatever they are both greater than 0, right? Because we can't have a negative number in our domain, right? Our domain has to be 0, greater than 0. All right, so let's do a couple of problems like that, just so you can see those in practice as well. All right, so say we have this problem. Natural log of x minus 3 equals natural log of 7x minus 23 minus natural log of x plus 1. So first things first, I got to condense both sides. I need a logarithm on one side and a logarithm on the other side. So on the left, I already have a singular logarithm, so that's good. So the natural log of x minus 3. On the right-hand side, I'm going to have to use my quotient rule. So this is going to be a quotient of 7x minus 23 over x plus 1. Okay, so now notice you've got a logarithm equals a logarithm. Fabulous. Okay, so because we have logarithms, they're both base e, I can just set x minus 3 equal to 7x minus 23 over x plus 1. And I will now need to solve that rational function. All right, so first thing I'm going to do is I'm going to multiply x plus 1 by both sides. On the left-hand side, I will FOIL that out, and you should get x squared minus 2x minus 3 equals, over here on the right, the x plus 1s will divide out, and I am left with 7x minus 23. All right, so this is going to end up being a quadratic. I'm going to put everything on one side, so I'm going to subtract 7x from both sides. I'm going to add 23 to both sides. So I get x squared minus 9x plus 20 equals 0. And that quadratic trinomial will factor. So that will be x minus 5 times x minus 4 equals 0. So that gives me two solutions, x equals 5, and I get a solution of x equals 4. Make sure that you check both of them. I cannot stress this enough, because you just went from a logarithmic equation and you changed it to a quadratic equation. Completely different family. So when you do that, extraneous answers could arise. Always important that you check, check, check. Every single question, check them both. Okay, in this case, it turns out both of them check, so you have two solutions, 4 and 5. So that would be my solution set. But always make sure you check both. Sometimes one might work and not the other. Sometimes both might not work. So always make sure that you check. I cannot stress this enough. All right, let's try another example. Similar, but different. All right, so we have got natural log of x minus 7 plus natural log of x plus 2 equals natural log of x minus 23. On the left-hand side, we do have that sum. So let's use the product rule to get that together. So that'll be the natural log of x minus 7 times x plus 2. And that's going to be equal to the natural log of x minus 23. Notice both sides are a natural log. So that means I can get rid of the natural logs and just set those two things equal to each other. So x minus 7 times x plus 2 has to be equal to x minus 23. So let's factor out, let's multiply out this left-hand side. So I get x squared minus 6x, minus 5x. Helps if I learn how to add. Say minus 5x minus 14 equals x minus 23. So this is a quadratic. I am going to get everything on one side, so I'm going to subtract the x from both sides. I'm going to add the 23 to both sides because I definitely want to have this equal to 0. So that leaves me with x squared minus 6x plus 9. And that does factor. That is x minus 3 times x minus 3. So one solution, it's a double solution, but only one. I get an answer of x equals 3. Okay, then it's important that you absolutely check this, because I have three things. This here tells me my domain, x minus 7 has to be greater than 0, which means x has to be greater than 7. I've already got a problem. Is this answer greater than 7? It is not. So this automatically fails. The one answer that I did get doesn't work. So this problem has no solution. The one answer that I did get was an extraneous answer. So this has no solution as its answer. So my solution set is empty. And that is why it's so important that you check everything when you're done. Don't get excited and be like, hey, I got an answer, woohoo! That answer might not work. So always make sure you're checking. All right, one more example. And again, if you would like to try this on your own, go ahead and press pause and we'll give you a second. All right, welcome back. Let's see how you did. All right, so first thing I'm going to do with this is I am going to get this left-hand side written as one logarithm. All right, so I'm going to pull up that squared on the log of x, so that's log of x squared. And then I have a subtraction problem, so that means I can put that together as x squared divided by 7. So log of x squared over 7 equals log of 567. So far so good. They're both logarithms of base 10, so I can get rid of those. So that would tell me that x squared over 7 equals, whoops, I was trying to write a 5 and that did not work out, 567. All right, to solve that, I would just multiply both sides by the 7. So multiply this side by 7, multiply this side by 7. So I get x squared equals 567 times 7 is 3,969. And boy, I'm definitely going to need a calculator for this. All right, so I'm going to take the square root of both sides. So square root, so I get x equals plus or minus the square root of 3969. Turns out that is a perfect square, so I get plus or minus 63. So two solutions. I have a positive 63, I have a negative 63. Now, because we are dealing with logarithms, again, log of x, that means that my domain has to be in any number that's greater than 0. This number is not greater than 0, so that is an extraneous answer. So that negative 63 does not check. So I only have one solution that will check, and that is the number 63. So again, we have had situations where none of the answers worked, one of them worked, both of them worked. Anything is possible. The moral of this story and the whole point of this lesson is to please make sure that you are always checking your work and checking your answers when you are done. All right, come back next time and we'll start putting all of this exponential and logarithmic work into practical practice with some real life problems. See you then.